Hi, everybody. This is Oğuz Gençoğlu from Root Signals, head of AI and one of the co-founders. Very nice to be here. Today, I'll be talking about evaluating GenAI applications in healthcare because there are a lot of people developing all kinds of interesting things with LLM, pipelines, workflows, agents, agentic stuff, automations in healthcare. And at Root Signals, we think measuring stuff and monitoring and observing those applications is at utmost importance. So I'll be saying a couple of words about that. We have a bunch of healthcare clients and some insights from that. So thank you in advance. Okay, what do we mean by evaluating? So we all know that evaluations, evals, has always been important. I mean, 10 years ago, we were developing machine learning applications in healthcare or in all kinds of settings. Of course, we measured it before deploying it to production. It was traditional discriminative models, not generative models, means we could calculate accuracies, F1 scores, precision, recall, basically ratios. If it's a computer vision model, it had its own metrics, semantic segmentations, object detections, any kind of classification. If it's forecasting, we had regression metrics. So of course we measured things, and it was very important, but it was not difficult because we just could calculate these ratios and it was just formulas. But now it is difficult with GenAI simply because, well, there's no such single class, there's no concept of that. It's just free text. And on furthermore, why it's difficult, these systems are non-deterministic. So LLMs behave unexpectedly. They are not deterministic systems. On top of that, they simply do not have self-reflection or self-consciousness, meaning that in your prompt, you cannot just write "do not hallucinate" and expect that it just doesn't work like that. So they don't have that sort of self-reflection. So there are all kinds of problems coming from these 2 points. On top of that, as if this is not this is not problematic enough, they have a thing called prompt in the first place. So there's this semantic guidance coming from the user or from some system that changes the behavior, the answer, the response of the LLMs and agentic pipelines. So in the end, there are infinitely many ways a response and output can fail or at least be suboptimal. These are stuff like hallucinations we are very familiar with, confabulations, inaccuracies. These LM applications we develop, they have biases. Maybe they talk a bit too much sometimes. They are diverging from business interests and things like that. So there are the failure modes are multidimensional. So it's very difficult to measure that without a systematic approach. On top of it, of course, one might ask, okay, can we still use some traditional metrics? And unfortunately, no. The traditional metrics are pretty much completely obsolete. And what I mean by traditional metrics, these are low-level machine learning metrics, stuff like blue, rouge scores, cosine similarities, and things like that. They are not only useful, they are in fact misleading. Actually, in my opinion, any kind of evals or evaluation framework, open source or proprietary, who actually provide these scores, they are completely misleading. I think that's a litmus test for the intentions and quality of these evaluation frameworks who seriously try to claim you can capture these complex things like hallucinations and all kinds of complex metrics we care about in healthcare with blue scores and rouge scores. And on top of that, lots of these metrics, for example, blue and rouge, they require a ground truth. I have a healthcare chatbot running in production. I want to detect hallucinations before showing to my end user. There's no ground truth, so we cannot rely on metrics that require ground truth. So we need something different. And a super simple example, I think every data scientist would understand what I mean by threshold metrics is cosine similarity. Um, just comparing embeddings, any kind of embedding from these two sentences. Let's say the first sentence talks about a patient diagnosed with type 2 diabetes, and a medication is prescribed to manage blood sugar levels. Doctor has some follow-up appointments. And the second one is a patient with hypertension is advised to take medication to control blood pressure, and doctor suggests lifestyle changes. Are these two sentences similar? Well, depends. In the context of managing chronic conditions, yes, there's some chronic condition and there's some sort of an intervention. Is the in the context of specific diagnosis? No. One is talking about the type 2 diabetes, the other one is hypertension. You can, if you calculate a cosine distance, you'll get some number, but uh, our LLM applications, measuring LLM applications, evaluating, monitoring these metrics. First of all, defining those metrics is not as easy as that. They are very contextual. Now, what I'm coming at is that, so how do we measure that? If I'm talking about all these problems, the solution to this is LLMs specifically tuned, optimized, and calibrated to perform evaluations. So this is called LLM as a judge. This is a term in the community, meaning that an LLM specifically grounded, fine-tuned, optimized, tuned to evaluate other LLMs. And this tuned, optimized, calibrated part is extremely important. And the reason is very simple. If we claim LLMs are unreliable, all kinds of LLM applications, they can fail in unexpected ways. You need to measure that. And if we put another LLM on top of it, one unreliable thing on another unreliable thing, without treating this evaluator, this LLM judge, as an unreliable thing itself, this whole thing crumbles. So if you can't trust the measurement device, what's the whole point? So that's why it's very important. Uh, these complex metrics we care about, they can only be measured by other LLMs, but it's very important that we can tune, monitor, optimize, calibrate these evaluators, these LLM judges themselves. And I have a couple of misconceptions about these LLM judges, and I'll be explaining five, six, seven of them. And the most important or most common is this misconception that, so what is LLM as a judge? It's just a prompt, right? Anyone can make a judge. You can just ask GPT-4 or Claude or whatever model, hey, rate this text in terms of medical jargonness and return a score between 1 and 10 and tell me why you gave that score. I mean, you can write that prompt and you will get a number from GPT-4, but producing a number it's easy. It's just this number is meaningless because LLMs are horrible with numbers in the first place, but also they are pretty bad if you don't know how to calibrate them, tune them. They will just blurt out the next most likely thing in the token space. So that's just how they work. So consistently producing a meaningful number is very difficult. And without proper engineering tuning, these judges have all kinds of biases. The evaluators, like LLMs themselves, have all kinds of biases, but there are specific biases when it comes to evaluation itself. For example, verbosity bias. This has been shown in all kinds of papers that LLMs tend to give higher score when they are evaluating long text. This is like a lazy teacher. If the student wrote this long essay, I should maybe give a high score kind of thing. So you need to calibrate the bias in all kinds of things, and it gets really complicated. On top of it, if you want let's say the example I just gave. Hey, evaluate this text in terms of formality or medical jargonness and give me a score and tell me why. If you literally actually use that prompt, LLMs are deep neural networks, and they work autoregressively. They just predict the next token. So if you write that prompt to any model, because in your prompt you said give me a score, it will first output a score, then it will make up a justification, reasoning for that score. It post rationalizes because it already gave you the score. So it's just predicting. So there's all kinds of details like that. So proper LLM as a judge, evaluator, is not just a prompt. And it just doesn't work like that. Second misconception, I mean, very common is judge models, these LLMs as judges, do not to be managed like other LLMs because of the, as I just explained, um, that's not the way to think about that. So these LLM judges, they need the same optimization, they same scrutiny as any other LLMs for latency, cost, and judging accuracy. So they need to be aligned with human preferences and human domain expert evaluation. And that's the only way they can match human agreement rates or disagreement rates. Otherwise, they don't make sense. So this is a misconception. Third one is a misconception of this antivirus kind of thinking. So many people think LM judges are only to block unwanted responses. This rare but catastrophic things, like some hallucination happened in my healthcare chatbot. This is not true at all. Uh, this is one use case, but as I mentioned, we care about complex metrics. Is this LLM pipeline I built? Is it talking with my policy rules? Is it complying with some healthcare policy regulation document? Is this thing talking about certain topics it shouldn't talk about? Is it talking too much medical jargon or not? Um, are the texts abbreviated or not? These are these are some certain metrics that you can build floating point scales, because surely some medical text is more contains more medical jargon than others, so it's not a black and white thing. And when you care about these metrics in real life in your applications, of course you want to be able to measure them in that sort of scale. It's not just 0 and 1 binary, but you want to be able to optimize and improve your applications across this floating point, this kind of scales. So LLM judges are not only for one-off binary detect hallucination or not kind of evaluations, but for all kinds of complex custom metrics you can think about. And they can be uh, metric outputs between 0 and 1, for example, with floating point, when you know how to tune them properly. The next misconception is, um, we get this quite a lot, and it's the following. People say when foundational models, frontier models, they become stronger and smarter, we won't need any evaluators and judges uh, because they'll be so good. Of course, this is just cope. It just doesn't work ever like that. Simply because, first of all, our when AI gets smarter, and that's for sure will happen, our demands and expectations from AI also gets more complicated. So we expect it to solve more complex problems, uh, really complex agentic pipelines, all kinds of complex things, more difficult things, and then AI will continue failing and dropping the ball in those cases, hallucinating, because the expectations are also getting more difficult all the time. So we will always need evaluation in that perspective. Uh, but also, secondly, evaluations are important because even if you have AGI or whatever you want to call it, we want to be able to use more efficient models. We want to perform a task, let's say a really truthful um, recommendation chatbot in or a patient assistant powered by the world's most powerful, smartest model. We for sure want to have the same accuracy and latency for this healthcare LLM application with a much cheaper model, uh, much energy efficient model. But you need to measure that. You need to be able to, if you wanna, if you want to switch to a smaller model, more energy efficient model, you should be very sure it performs as good as the most powerful model, and you need to be able to measure that. So um, evals and judges and measurements will always be important. And another misconception, and this might be my favorite, that um, lots of people say, okay, LM judges are only for pre-production. So this is while developing your applications. Should you LM judges or evaluators, they are just for deciding, is this LLM better than this LLM? Is this prompt better than that prompt? Is this RAG hyperparameters, let's say chunking strategies, embedders, re-rankers, all that stuff better than that? And then once you develop, because you have measurements, you develop in confidence and you converge to a solution. You know how that solution performs in terms of complex metrics such as hallucination rates, answer relevance, compliance to some medical instructions, and all kinds of things. You are good. That's true. You have to work like that, but that's not the only use case for judges. So in reality, there's a great Nature paper actually. LLMs start to perform complex tasks before being flawless on very easy tasks. I will repeat that. This is very important. Our frontier models currently coming from all these labs, they actually start to perform really, really complex tasks, but they still fail. And there are like thousands of examples, and you know that they still fail in extremely simple tasks. What does that mean? This immediately means there's no reliable zone. There's no there's no threshold, there's no line you can draw and say, hey, these tasks, this zone, this kind of tasks, I can completely rely on LLM without measurements. They are working perfectly. There's no such zone. This is quite different than humans actually. So let's say a medical translator. This person can translate, if this person, world's best medical translator, it can translate complex, long medical text from one language to another, for sure, this person can translate a very simple text. You expect that. But this logic doesn't work with LLMs. So there's no reliable zone. So you need to measure also in production real time. We call it online evals or live guardrails, simply because of that reason. There's an amazing Nature paper explaining this phenomenon really in a simple way, and the idea is a bit actually more shocking than you would expect. Actually, larger and smarter models are less reliable. Let me repeat that. Larger and smarter models, they actually perform complex tasks. Their maximum is really high, but they are less reliable. You can definitely not draw a line. Hey, these kind of tasks, this region, they will work flawlessly. So larger models are less reliable, and the most important thing in healthcare applications is reliability, of course. And finally, the misconception of you always know what to measure from the get-go. This is not the case. So in reality, you don't. You want to monitor your application. You want to see how your end users are using, how LLMs are responding. Then you build your custom evaluators, custom judges, tune them. So it's an iterative process, but you need a systematic life cycle management of all these judges. You need to be able to evaluate these judges too, as I mentioned. And without this kind of a systematic tool platform, this gets chaotic really quickly. That's what we are building at Root Signals. So the solution to any kind of LLM application, LLM agent, workflow, whatever you want to call it, measuring those is properly tuned, optimized LLM judges. The takeaway from this is you need to measure and log everything, trace everything, especially in healthcare. You want to be audit ready, and LLMs are unreliable. So you want to log and measure every single decision, why you decided this LLM and this prompt, and why this prompt performed better than this other prompt when building your applications, because you want to be audit ready, and LLMs are unreliable. While developing, you should do that, and of course, you should continue measuring in production because LLMs hallucinate. And things you care about in reality are complex metrics. They can only be implemented as LLM as judges. But because LLMs are unreliable, LLM judges are LLMs. You need to also be able to create, measure, optimize the judges too, and optimize in terms of evaluation performance, latency, and cost. So evaluations is hard, and this whole life cycle management of judges is a pain in the back. You don't want this chaotic Jupyter notebooks and Python scripts and all kinds of things. What was the data version? What was that prompt version? You want a systematic tool. Root Signals is the only tool in the market evaluation platform focusing only on this judge optimizations. You can build, tune, and calibrate these judges, evaluators with Root Signals. And these judges are not only for guardrails, they are for all kinds of custom metrics, and we are not competing with open source libraries. We are agnostic to any LLM or generative AI framework or infrastructure. We support all of them, and we provide full observability and audit trail. So please give it a try. We have a Python library, pip install. We can read from our docs too, and I'll be happy to take your questions in the chat now. Thank you.